10.6 is on surface area. Shh, guys, surface area. Hey, of prisms and cylinders. So definitions, what if I have matching? Will you guys be able to do these definitions? No. All right, a prism. Shh. A prism is a polyhedron with two congruent faces called bases that lie in parallel planes. We've talked about that, a prism versus a pyramid. Lateral faces are the sides, the faces that are along the sides, right? So lateral means side. So like this would be a lateral face, and this would be a lateral face. And then the bases are the top and the bottom. Now, I say that, and then some people take it very, very literally, right? If you have a shape where you have, you don't have to draw this, because I know some of you guys have trouble with things like this. But if we have a, let's say a hexagonal prism. Ooh, mine's a struggle too. If I have something like that, what are my bases? The two like ends, like the front and the back. Does that make sense? So don't, like when I say top and bottom for bases, it's not always the top and the bottom. It's just the two things that are parallel to each other, right? All right, so lateral edges, the segments connecting the corresponding vertices. So this would be like a lateral edge right here. The altitude is the height. It's the distance that separates the two bases. A right prism is one that's straight up and down, and an oblique one is one that looks like this. So an oblique can be sideways. You basically still find it the same way. All right, and then the slant height and surface area and lateral area, we have those as well. So we talked about slant height last time, so we'll have the same kind of thing. So it says find the surface area of the following figures. So we could have formulas for all of these things. They're all going to end up being the same formula. So if I was trying to find my width, length, and height, remember how we did this on the board? We said, oh, I'm going to have 2 of my length times heights, and I'm going to have 2 of my width times heights, right, the front and the back. And I'm going to have 2 of my, what was that, width times length?
Yeah.
Like that. And that ends up being the surface area. Okay, so you could memorize that formula if you want to, but again, you don't have to. You can always break it up into its pieces. So what we talked about a couple minutes ago is we said if we unfolded the piece of paper that created the lateral edges, we ended up having a piece of paper that looked like that. This distance here was the perimeter of the base, right? So it ended up being perimeter times height plus our 2 area of the bases, right? You could write it like that as well. So a cube. If I have a side, and a side, so my little cursive S's, what's the area of just like the front? It would be side times side, right? How many of those do I have?
4.
Think about a dice. 6, right? I have the top, bottom, right, left, front, back. So the area for a cube, or the surface area for a cube would be what?
6s.
6s squared, exactly. Now, could you do the same thing? Could you do perimeter times height plus 2 times base? Sure, you could do that. All right, cylinder. Oh, mine got cut off a little bit. Is yours good in your notes? Oh, it got cut off too. All right, so let R be the radius of the circular base and H be the height of the cylinder. So again, let's think about kind of like we did with that piece of paper for the sides. What if I have a piece of paper and I roll it into a cylinder? Okay, what would you call this distance along the top of that piece of paper? Would I call it perimeter though when it's a circle? Yeah, I call it the circumference. So this distance around, if I cut the piece of paper right there, I have my height here, and this distance around, as you guys just said, is my circumference. Okay, so this formula is going to be kind of the same. We're still going to have the area of the bases, right? So I'm going to have 2 times my area of my base, my top and my bottom, but I'm going to have my circumference times the height instead of perimeter times height. It's the same thing, right? You can call it perimeter if you want to. Okay, let's get a little bit more fancy with this. What is big B? It's the area of the base, right? What types of bases do we have in this case? Circles. And what's the area of a circle?
Pi r squared.
Pi r squared. So we could write this as 2 pi r squared plus, what about circumference?
Plus pi d.
Pi d, or 2 pi r, right? Or pi d if you want. So I have 2 pi RH. So you might see that as the area, the surface area of a cylinder as well. Does that make sense on where that comes from? Okay, so the key is to not try to memorize everything because you're never going to be able to memorize everything, right? To know where these things come from. That's the key. All right, so let's try some of these. So it says the surface area of a right prism is going to be S is equal to 2b plus perimeter times height. And for a cylinder, it's going to be kind of the same thing. It's going to be 2b plus the circumference times height. So if we have a right rectangular prism, it means it looks something like that. I know some of you guys have a struggle in drawing those. Poor Ian. So you have a height of 10, a length of 8, and a width of 3 inches. So you can do your right side, left side, front side, back side, top and bottom, and add all those areas together. You can always do that. So don't feel like I'm like teaching all this new stuff and you're like, oh, I have no idea what these formulas are. You can always do that. Or you can do surface area is equal to 2 times the area of the base plus the perimeter times the height. So let's talk about the perimeter of a base. What is the perimeter? 8 plus 3 plus another 8 plus 3. 22, right? What's the height? 10. All right, how about the area of the base? 24, right? 8 times 3. So we end up getting 48 plus 220. So if I add those together, I get 268. Okay, since it's an area, it's in square inches. All right, let's pause there so you guys can go on your break. All right, so number 2, so find the surface area of a right triangular prism with equilateral bases. So some of you guys are saying, like, how do I even draw this? It's okay if you can't draw it. But basically, I always draw, like, the little triangle. And then it's like that, right? So it's equilateral bases. If you want to just draw an equilateral triangle and just think, okay, this is one of my bases, that's fine, okay? So we want to find the surface area. So we know the surface area, as we just talked about, is the perimeter times the height plus 2b. So we want to know what the area of the base is. And some of you guys might remember the formula. We just talked about it. What's the area of an equilateral triangle? Still crickets? Oh, man. Root 3 over 4 side squared. And you can get that by breaking it into 30, 60, 90 triangles and finding that height, which ends up being whatever the side length was divided by 2 and then times root 3. So our area of our base is root 3 over 4. And then our side length, the equilateral base has a side length of 12. So it's going to be root 3 over 4, 12 squared. So we're going to have 2 times root 3 over 4 times 12 squared. All right, then we need the perimeter of the base. So the perimeter of the base is going to be 36, and we want the height separating those 2 bases. So not the height of the triangular base. Like a lot of people will think it's like this, like the red line. It's not the red line, right? It's the height that separates our 2 bases. So what is that going to be? Do you guys have 16 for that? Because it's given in the problem. So it says, and the height of the prism is 16. You see it?
I'm really on fire today.
It's a struggle having a double, man. So 576, so we do 144 divided by 4 times 2. All right, so 72 root 3. Is this some song I should know? All right, so we get that. So I'm fine if you can leave it like that. That is a number. It would be that number, inches squared, or centimeters squared, I guess. But if you want to find it so that you multiply that by that root 3, so it's kind of all together, you could say, oh, that's around 700.708 centimeters squared. Okay, that's fine as well. Okay, did anybody get that? No. What'd you have trouble with?
I just, yeah, I did it
You did it all in the calculator, is that what you said? You did it all what?
along with you.
along with me. Okay, you just weren't fast enough. I was so speedy. All right, so suppose a water tank in the shape of a right circular cylinder. So we have a water tank. It looks like this. Is 30 feet long and 8 feet in diameter. So 8 feet along the top and 30 feet like this. How much sheet metal was used in its construction? So this is not asking for a volume, it's asking for a surface area, right? So we're talking about the metal that goes around this tank. So we can say our surface area is going to be the two bases, so 2 times the area of the base. In other words, 2 times the pi r squared. And then we want that lateral area. Do you guys remember how we found that lateral area? We took that piece of paper and we rolled it across. What was the lateral area? It was the circumference times the height, right? So instead of writing pH, I'm going to write circumference times height. Same thing, though. So I'm going to get 2 pi r squared, and r is 4, plus my circumference, which is 2 pi r, and then my height, which is 30. So if you want me to write it like 2 pi r squared plus 2 pi r h, I could do that as well. Do you guys know where I'm getting that from?
Where'd you get the 4 from?
The 4 is going to be the radius because the diameter was 8.
And then, how'd you get the 3rd? Like, how did you find it?
How did I find the 30? The 30 was given in the problem. It's 30 feet long, like 30 feet in height, I guess I should say. But this tank might be like laying sideways. That's why I might use like the word long. Have you guys seen like water tanks that are sideways? I always think of like there's like the natural gas tanks that are sideways. I don't know if you've seen those. I'm really old and people used to have those in like their backyard. All right, so we get 16, I know, times 2, so 32 pi, plus 120 times 2, so 240 pi. So I believe you get 272 pi. Okay, again, if you don't like having the pi there and you want to multiply it out, you could. It would be 854.513 square feet. Okay, so number 4, so it says solve for y if you're given that the surface area is 160 square inches and the dimensions of the rectangular prism. Oh, that one got a little rogue on me, a little crazy. There we go. All right, is 4 by 4 by y. Okay, it doesn't matter which one was the 4, the 4, or the y, right? But we know that our surface area is going to be our perimeter times our height plus 2 times the area of the base. So our perimeter of the base, the way I drew it, it's going to be 4 plus 4 plus 4 plus 4. So 16, right? But some of you guys might have drawn it so that the y was here. If you did, you would have 4 plus y plus 4 plus y, which would be 8 plus 2y. That's fine as well. It doesn't matter. Okay, so we got 16 there. And then times our height, which is y, plus 2, and then the area of the base. So our area of our base is going to be 4 times 4, which is 16. All of this needs to equal 160. Okay, this is not a hard equation to solve. You guys got this. So you get 160 is equal to 16y plus 32. We subtract the 32 over, we get 128, Colin, up there. And then we do 128 divided by 16. So we get y is equal to 8. Okay, not bad at all. All right, does this all make sense? We feel pretty good with surface area? All right, let's try a couple more. Yeah.
When's our final test for this?
Probably Friday or Monday.
Friday?
Friday or Monday. It's just going to be a quiz. It's not going to be a big test. A quest, yes. All right, so number 5. So find the surface area of the right cylinder that has a base diameter of 8 inches and a height of 15 inches. Okay. So we want our right circular cylinder that has a base diameter of 8. So that means we're going to have 4 there and a height of 15. Oh, I think we're good. We don't have to do that one. Let's skip this one. So so let's look at these other ones. I think we're good on 6. I think we're good on part B on number 6 as well, 6A and B. Look at part C, though, the third one. That's a little challenging. Yeah.
You have to complete the circle and then take half of what you find. What would be.
So, like you're saying, this would be like a semicircle right there?
Yeah, but then
Yep.
can't you just finish the circle and then solve it as if it was a full circle and then take half of it?
That's kind of a good idea. Like he's saying, you know, maybe you could like make it an entire circle and do a cylinder and then find half that surface area. That would actually work in this case because you have half of both the bases, right? You have a semicircle for the two bases, and then that half of the circumference ends up being half going around. So you could do that way. Okay, I would probably just kind of do it all together, and I'd say that these are my, like this is my base, and then I have another base behind it. Do you guys see that? And I would find the area of that base. Okay, but when I find the area of the base, I'm doing what Charlie says, and I'm finding the fact that I have like a semicircle and a rectangle. Do you guys see it? So if I do a rectangle plus a semicircle, okay, that rectangle is 24 times 12. And that semicircle area is 1/2 times pi r squared. Okay, tricky part, what's r?
6.
Ah, it is 6. Do you guys see it? Because we had 12 over on that other side. This 12 was this distance. Well, it's the same as this distance over here. So it's 6 squared. So 24 times 12 ends up being 288. And then I have 6 squared is 36. Divided by 2 is 18. So I have 18 pi. So I have 288 plus 18 pi, which is like 344 point something, 549. Okay. So let's put this all together. So let's say our surface area is equal to 2 times the area of the base plus that perimeter times height. Okay. So we have 2 times that 344 number, but we need to do plus the perimeter times the height. Now height in this case, what is the height? It is, it's not 24 actually. The height is the distance that separates the two bases. Okay.
Oh, 10.
It's going to be 10, yeah, this is the height. So our height, which is between the two bases. Okay, so we at least have that height, which is 10. But then we have perimeter. Little tricky. So the issue with the way that Charlie said to do it is I agree with like the cylinder thing. That cylinder is half that cylinder. But when you talk about the surface area of the rectangular part when you divide it, do you guys see how that rectangular prism is missing something?
It's missing an edge.
It's missing one of those sides, right? One of those lateral faces. Do you guys get it? It's like inside this shape. So we can't count that in the surface area. So doing it this way and thinking of the whole thing all together is probably better, so you don't have to think about subtracting that part out. But you could do that. You could find the rectangular prism plus half of a cylinder, their surface areas, and then subtract out that side. Yeah, Rhett?
When I do that first part,
Uh-huh.
you do 24 times 12.
Yep.
Right. Wouldn't that be saying if the rectangle extended out to like the very end? Of
Actually, it ends up, do you see how this ends right there? It's saying it only goes to that.
Okay, I thought it was.
Yeah, it's kind of hard to tell with the drawing in it. All right, so let's talk about this perimeter. So the perimeter I'm drawing in black. Do we see all of this? We want this perimeter. Okay, so we have 12 plus 24 plus another 24 plus, how do I get this part right here? So we had 24, 24, and 12. And then this is half of the circumference, right?
Isn't that diameter 12? Like the dotted line?
It is 12. So we're going to have a radius of 6. It's pi times diameter, or 2 pi r. But you're saying divide by 2 because it's half of the circumference. So it's just pi times the radius, right? So it's going to be Ooh, this is tricky. Are we ready for it? So what did we have? We had 12 plus 24 plus 24, so I'm going to write 48 plus pi times r, so 6 pi. Woo-wee, that's a lot. All right, so I'm going to multiply by 2, and then I'm going to add 12 plus 48 plus 6 pi multiplied by 10.
Why is it multiplied by 10? Oh, the height.
Yep, the height, yep. So I got 1477.593 square inches. Ooh, that's definitely a marker drop problem. That's a hard problem. Okay, but you guys understand this concept of surface area? So we're going to do the 2b plus perimeter times height every single time, or you can break it into the different pieces if you want. So I could have done the front and the back, the top and the bottom, the right and the left. Okay? All right, let me stop.